Hello everyone. So here we shall solve some KCET previous year questions on the chapter current electricity. So if you have any questions regarding any steps of the solutions, any of the questions or any other kinds of doubts if you have, then please write us in the comment section. Um, and in any other chapter of physics, if you feel difficulty, then please also mention the name of that chapter in the comments section. Then we shall give more priority on it and solve more and more questions on that chapter. Also, some important homework questions will on every chapter will be uploaded in the Sapience education application. So please install our Sapience education application. Link has been provided in the description. So here we shall start from the very first question, current electricity. So the first question says that a battery, one battery is there, is having EMF 10 volt and internal resistance R is 3 ohm. It's connected to a resistor. It's connected to resistor. Then the current in the circuit, current I in the circuit is 0.5 ampere. The terminal voltage of the battery when the circuit is closed is. So here there is one switch. So when the switch is closed, then what is the terminal voltage of the battery? So when the cell is under working condition, so then the terminal voltage will be, or V will be equal to E minus IR. So this will be the terminal voltage. This will be 10 minus 0.5 into 3, which is 10 minus 1.5, which is equal to 8.5 volt. Option D is the correct answer. Then question number 2, it is told that the electron drift speed is small and the charge of the electron is also small, but still we obtain a large current in a conductor. This is due to so we know that the current in the conductor is given as NEAVD. NEAVD, where VD is the drift speed and E is the charge of the electron. So E is also small, VD also small, but N, which is the number density of electrons, is very high. It's very high. That's why we obtain large current in the conductor. Option D is the correct answer. Then in question number 3, it is told in the circuit shown the value of I in ampere is. The value of I in ampere is. Find that. Now here the equivalent resistance here. So this is 4 ohm and these two 4 ohm are connected in parallel. That's why their equivalent is 2 ohm. Two resistors are connected in parallel for 4 ohm each. Therefore their equivalent is 2 ohm. And here we have 4 ohm series with it. Here we have 1.6 ohm and this is 4. So now the equivalent resistance of these two will be, this is 6 and this is 4. The equivalent resistance is 4 into 6 by 4 plus 6. So this is 24 by 10, that is 2.4. So this is 2.4 ohm. This is 4 volt. This is 0.6 ohm. Now 1.6 plus 2.4 will be 4 ohm. Therefore the current, the cell, the current through the through the battery or cell, that is V by R equivalent, where V is the voltage of the cell or the battery. So this is 4 volt divided by 4 ohm. So that will be 1 ampere. 1 ampere current is flowing from here to the cell. This is 6 ohm. So therefore, how much current will flow through this? So that is 4 by 4 plus 6, that is 4 by 10 into 1 ampere. That is 0.4 ampere. So 0.4 ampere is the current I. Let's say this is I1. Okay. So I equal to 0.4 ampere. So option C is the correct answer. So here what we did, actually the current will be it will be divided in the inverse ratio of the resistance. Means that suppose I current is flowing, I1 current is flowing, and here we have R1 and here we have R2 connected in parallel. So R1, R2 are connected in parallel. Then here through R2, the current which will flow, that will be R2 by R1 plus R2 into I1, and the current which will flow through R1, that will be R2 by R1 plus R2 into, no, so it will be through R2, the current which will flow, it will be R1 by R1 plus R2 into I1, and so through R1, the current that will flow, that will be R2 by R1 plus R2 into I1. So current, so when resistors are in parallel combination, so it means that in parallel combination, current is divided the inverse ratio of resistances. Inverse ratio of resistances. So question number 4, it is told a 30 volt 90 watt lamp is to be operated on a 120 volt DC line. So there is a lamp. So across this is 30 volt and it consumes 90 watt, and a 30 volt 90 watt lamp is to be operated on a 120 volt DC line. This lamp is to be operated on a 120 volt so here one external voltage source, some battery is there, voltage is 120 volt. For proper glow, a resistor of dash ohm should be connected in series with the lamp. So one resistor for proper glow, how much resistance should be connected with in series with the lamp? That is being so across the lamp 30 volt should be the potential difference across it. 30 volt is the potential difference across this. So it means that across the resistance the potential difference should be 90 volt. is that how much current should flow. It should be like is equal to V is equal to V is equal to IR. So how much current should flow through the resistor? Yeah. So 90 volt, that should be equal to I into R. So we have to find the current first, then we can find the resistance. Okay, so across the lamp, V square by R across the lamp, 30 square V square by R, R1. Let's say the resistance of the lamp is R1, that is equal to the power consumed, that is 90. Therefore 900 by R1, that is equal to 90, means that R1 is 900 by 90, that is equal to 10 ohm. This is 10 ohm. So therefore the current will be equal to V by R, V1 by R1. So V1 is 30 volt divided by R1, that is 10. So this is 3 ampere. So 3 ampere current is flowing. So therefore I is 3 ampere. Therefore 90 equals to 3 into R. So then we can find how much resistance should be connected in series with the lamp. R should be 30 ohm. Option D is the correct answer. Then a battery consists of a variable number of identical cells, each having an internal resistance R connected in series. So here they are each having internal resistance R, and so they are identical cells. It means their EMF of those cells will be also same. So R, then this is also R. So like this, n number of cells are connected in series. The terminal of the battery are short circuited. The terminal is short circuited. A graph of the current I in the circuit versus the number of cells will be as shown. So the current I, that will be given as E equivalent by R equivalent. E equivalent is the sum of all the EMFs, that is N into E, divided by R equivalent is N into R, N into R. That will be equal to E by R. That means that the current in the circuit is independent of the number of cells. It means that the current will be constant. So I versus N, the function will be this. Option C is the correct answer. Then in question number 6, it is told a current of 6 ampere enters one corner P of an equilateral triangle. 6 ampere enters one side of an equilateral triangle. Now this is 2 ohm, this is also 2 ohm, this is also 2. This is I2, this is I1. Q is also R, is also point P. Current of 6 ampere enters one corner P of an equilateral triangle PQR having 3 pairs of resistances 2 ohm each and leaves by the corner R. Then the current I1 and I2 are. Current I1 and I2 are how much? Okay, that is big. So here the net current 6 ampere will again come out. Okay. So here the equivalent resistance. So this I can tell this circuit is equivalent to saying like this is 6 ampere. This is your 2 ohm plus 2 ohm. These two are connected in series now. So this is 4 ohm and this is 2 ohm and this is now 6 ampere. So it means that through this I1 current is flowing and through this 2 ohm I2 current is flowing. So now I2 will be equal to, so current will be divided in the inverse ratio of resistances when the resistors are connected in parallel. When resistors are connected in parallel, then current is in the inverse ratio of resistances. So I2 will be 4 ohm by 4 plus 2 into I, that is 6. So this will be 4 ampere. So I1 will be 2 ampere. So I1 is 2 ampere, I2 is 4 ampere. So 2 ampere and 4 ampere. So option A is the correct answer. Then in question number 7, it is told in the Wheatstone bridge, the Wheatstone network given P is 10 ohm. So this P is 10 ohm and Q is 20 ohm, R is 15 ohm and S is 30 ohm. G, this will be 6 volt. Now the current passing through the battery of negligible internal resistance is current passing through the battery will be how much? So here the ratio is equal to this. So now 10 by 20, that is equal to 15 by 30, that is equal to half. So it is a Wheatstone bridge. So no current will pass through this galvanometer G. So therefore this is equivalent to, this will be 10 plus 15. These two are connected in series. So 25 ohm. These two are connected in series, that is 3 ohm. And this is the cell, 6 volt. So their equivalent resistance, R equivalent is 25 into 50 by 25 plus 50, that is 75. 25 3 is 75, so 50 by 3 ohm. Now therefore the how much current will flow will pass through the battery of EMF 6 volt. I is 6 volt divided by R equivalent, that is 6 by 3 by 3 is 18 by 50. That is 18 by 50, that is equal to 36 by 100, that is 0.36 ampere. Option A is the correct answer. Question number 8, it is told current of 5 ampere is passing through a metallic wire of cross-sectional area. A current of 5 ampere is passing through a metallic wire. Current of 5 ampere is passing through a metallic wire. Okay. Area of cross section 4 into 10 power minus 6 meter square. If the density of charge carriers in the wire is 5 into n, that is 5 into 10 power 26 per meter cube, the drift velocity of the electrons will be. So we know that I is equal to NEAVD, where A is the area of cross section and VD is the drift velocity. So here we have to find drift velocity VD, that is I by NEA. Now I is given 5 ampere, so that will be 5 ampere divided by 5 divided by number density of electrons, that is 5 into 10 power 26, and E is 1.6 into 10 power minus 19 into area of cross section is 4 into 10 power minus 6. 5 and 5 will cancel out, so this will be 1 by 1.6 into 4 into 10 power 26, 10 power minus 19 into 10 power minus 6. Okay. 0.6 into 4 into 10 power 26, 10 power minus 19, 10 power minus 6. So this is 1 by 4, 64 is 64, so 6.4 into 10 power 26 minus 19 plus 6, that is 25. So this is 1 by 64. 1 by 64 meter per second. So this will be equal to, I can tell, 100 by 64 into 10 power minus 2. This will be 4, 16 for the 64, 4, 25 the 100. So this is 16, 1 the 16, and then 9, 16, 5 the 80, 100, 16, 6 the 96. So this is 1.56. So this is approximately 1.56 into 10 power minus 2 meter per second. So option B is the correct answer. Then question number 9 is told two bulbs rated 25 watt 220 volt, 100 watt 220 volt are connected in series to a 440 volt supply. Two bulbs are there. One is 25 watt to 20 volt, and this one is 100 watt 120 volt. So they are connected in series to a 440 volt supply. Then the 100 watt bulb fuses, 25 watt bulb fuses, both the bulbs fuse, neither of the bulb fuses. So that we have to find. So here R1 20 volt. So let's say the resistance of the first bulb B1 and B2 you can tell. So for the first bulb, the resistance is suppose R1, and for the second bulb, the resistance is suppose R2. So now therefore R1 will be equal to V1 square by P, V1 square by P1 actually. So this is 220 into 220 divided by 25 watt. So this is 25 for the 100. So this is 22 into 22, that is 484 into 4 ohm. This is 4. Okay. And R2 will be equal to also V2 square by P2, that is equal to V2 square 220 into 220 divided by 100. So this will be 484 ohm. So now therefore their equivalent resistance are equivalent, that is equal to, they are connected in series, so which is R1 plus R2, so that will be 5 into 484 ohm. So now therefore the voltage drop across R1, that is V1, so that will be equal to I into R1. So how much current will flow? That will be V by R equivalent, that is 440 divided by 5 into 484. V by R equivalent into R1, that is 484 into 4. So that is 4 by 5 into 440, that is 5 8 the 40, 5 8 the 40, 4 8 the 32, 4 8 the 32, then 4 8 the 32, 35, 352 volt. So therefore the power consumed will be also higher. So this is more than the rated voltage. And V2, that will be I into R2, that is 440 by 5 into 484 into 484, that is equal to 1 by 5 into 440, that is 88 volt. So it means that the second bulb will not fuse, only the first bulb will fuse. It means that the 25-watt bulb fuses. So therefore the answer is, therefore the 25-watt bulb will fuse. It means the option B is the correct answer. Since why here we have found that the voltage drop across the bulb 1, that is more than the rated voltage, which is 220 volt. But in case of the second bulb, the voltage drop across it, that is less than the rated voltage. So it means that the second bulb will get fused. The second bulb will not get fused, but the first bulb will get fused. Okay. Then in question number 10, the current passing through the ideal ammeter in the circuit given below is. So here this is 4 volt. The voltage of this battery is 4 volt, and 1 ohm is its internal resistance, and so this is 2 ohm, this is 2 ohm resistor, this is also 2 ohm resistor. The current passing through the ideal ammeter. Okay, how much current will pass through the ideal ammeter? So this is the ammeter, this is 4 ohm. So how much current will pass through the circuit? So that will be, actually ammeter should be connected in series. Okay, so therefore here, so 2 ohm and 2 ohm are connected in parallel, therefore their equivalent is 1 ohm. Therefore the equivalent resistance is, therefore the R equivalent, that will be equal to 1 ohm. So this equivalent is 1 ohm, and this equivalent, this one is 2 ohm. So 1 ohm plus 2 ohm plus 1 ohm plus 4 ohm. So this will be equal to 1 plus 4, that is 8 ohm. So therefore the current in the circuit, that will be equal to the EMF of the cell divided by R equivalent. So that is 4 volt divided by 8 ohm. So that is 0.5 ampere. So option D is the correct answer. In question number 11, it is told a metal wire is subjected to a constant potential difference. When the temperature of the wire increases, the drift velocity of the electron in it, okay, subjected to a constant potential difference. One metallic wire is there, subjected to a constant potential difference. So it is a DC voltage source or a DC battery, you can tell, DC battery or voltage source. Since the voltage should be kept constant, means the potential difference is kept constant across this metallic wire, metal wire. So when the temperature will increase, temperature increases, the drift velocity will become how much? Okay. So we know that V is equal to IR. So I is equal to V by R. So V is constant, but when temperature will increase, the resistance will increase. So the current should decrease. So the current will decrease, and the current is given as NEAVD. So N, E and A, these are constants. So VD will decrease. So it means that the drift velocity of the electron will decrease. So the drift velocity decreases, but the thermal velocity will increase. Thermal velocity means the thermal velocity is proportional to root over kt. It means it is proportional to the square root of the absolute temperature of the wire. Therefore, the thermal velocity will increase since the temperature increases. It means drift velocity decreases and thermal velocity of the electron increases. So option B is the correct answer. Okay, then question number 12, the equivalent resistance between the points A and B is. Equivalent resistance between the points A and B is. So this circuit can be equivalently drawn like this, that this is 15 ohm, this is also 15 ohm, this is R, this is R, this is R, and these two are not connected, R ohm, this is also R. So their equivalently this will be 2R and R, their equivalent is 2R into R by 3R, that is 2R by 3. So this simply I can write it like this. This part is R, this part is the resistance R, and here we have 2R by 3, and this is also R. Here we also have their equivalent is 2R by 3. Since 2R and R are connected in parallel, this R and R are in series actually, so their equivalent is 2R. 2R by 3, then so across the points A and B we have to find, so therefore this can be written as R plus R plus 2, so 2R plus 2R by 3, since all these three resistors are connected in series, this will be 6R plus 2R, that is 8R by 3. So therefore R equivalent will be, so now 8R by 3 and 2R by 3 are connected in parallel. 2R by 3 and 2R by 3 are connected in parallel. R equivalent is 8R by 3 into 2R by 3 divided by 10R by 3. So this will be 16R square by 9. 16 to 3 by 10R. 3 3s are 9, so R will cancel. Then 2 5s are 10, 2 8s are 16. Sorry, here actually equivalently it can be written like this. This is R, this is 2R by 3, this is again R. Here again this is 2R, this is again R. So therefore R equivalent, if you have to find, then 1 by R equivalent, that is equal to 1 by R plus, okay, 1 by R plus 1 by 2R plus 1 by, this will be 2R plus 2R by 3, that is 8R by 3. This is 3 by 8R. So their LCM is 8R. This is 8 plus 4 is 8 plus 3, that is 15 by 8R. Therefore R equivalent is 8R by 15. So that will be 8 by 15 into R, that is 15 ohm. So that is 8 ohm. So option D is the correct answer. Then in question number 13, it is told the potential difference between A and B in the following figure is the potential difference between A and B. So if we apply the KVL, which is the loop rule, it is VA minus 6 into 2 is IR, then minus 12 volt minus 12 volt minus 12 volts, then this will be plus 9 into 2 plus 9 into 2, then plus 4 minus 5 into 2, that is equal to VB. Therefore VA minus VB, that will be equal to 6 into 2 plus 12 minus 9 into 2 minus 4 plus 10. This will be equal to 6 to 12. 12 plus 12 is 24 plus 10 minus 9 to the 18 minus 4. So this will be 18 plus 4 is 22. So 24 minus 22 is 2. 2 plus 10 is 12. 12 volt. Actually here I think this current direction is wrong. Should be minus. This should be also plus, minus, plus 18. So this will be, so 20 plus 28, that is 48 volt. Option D is the correct answer. So here one thing was wrong, that this direction of current should be like this. It should not be this way. So then question number 14, three resistors 1 ohm, 2 ohm and 3 ohm are connected to form a triangle. 1 ohm, 2 ohm and this is 3 ohm. Across 3 ohm resistor, 3 volt battery is connected. A 3 volt battery is connected. The current through the 3 ohm resistor is how much? How much current will flow through the 3 ohm resistor? So now this equivalently can be drawn as, this is 3 ohm, since why 1 ohm and 2 ohm are connected in series. So this is 3 ohm and this 3 ohm and 3 ohm are connected in parallel. Therefore same resistance, therefore same current should flow through each of them. So now their equivalent resistance is 3 by 2 ohm. So therefore the net current, that is 2I. So 2I, that will be equal to V, that is 3 by R equivalent, which is 3 by 2. So that is 2 ampere. Therefore I is equal to 1 ampere. So 1 ampere current will flow through each of them. So the current through the 3 ohm resistor will be 1 ampere. So option B is the correct answer. Then the accurate measurement of EMF, can be obtained using multimeter, voltmeter, potentiometer, voltameter. Okay. So by using potentiometer, the EMF can be accurately measured. The rule is that using potentiometer, the EMF of a cell can be measured, and its ratio can be found also. Ratio of the EMFs of two cells can be found, and the value of the internal resistance also can be measured by using potentiometer. Option D is the correct answer. Question number 16, it is told the resistance of a wire at 300 Kelvin, the resistance of a wire at 300 Kelvin is found to be 0.3 ohm. If the temperature coefficient of resistance of the wire, that is suppose alpha is the temperature coefficient of resistance, that is 1.5 into 10 power minus 3 Kelvin inverse, then the temperature at which the resistance becomes 0.6 ohm is. So we know that R at any temperature T, RT, that is given as R naught into 1 plus alpha delta T. So with temperature the resistance increases. So therefore the new resistance is 0.6 ohm, that is equal to R naught, is at 300 Kelvin, that is 0.3 ohm, will be equal to 1 plus alpha, which is 1 plus 1.5 into 10 power minus 3 into T minus 300 Kelvin. Now therefore T minus 300, that will be equal to 0.6 by 0.3 minus 1. So this is 2, 3 to the 6, 2 minus 1, that is 1. So T will be equal to, so sorry, T will be 1.5 into 10 power minus 3 into this equal to 1. Okay, so T minus 300, that will be equal to 2 minus 1 is 1. So 1 by 1.5 into 10 power minus 3. This will be 10 power 3 divided by 1.5. So this will be, I can say 10, 15 by 10 I can write. 10 into 1000 by 15. 5 to the 15, 5 to the 10. So this is 2000 by 3 Kelvin. This will be approximately 3, 6, 18, 3, 6, 18, 20. 6, 18. So actually the temperature, so R naught is the resistance at 273 Kelvin. R naught is the resistance at 273 Kelvin. So this one we cannot use. So 273 Kelvin. So this will be like this actually. So RT equals to R naught into 1 plus alpha delta T, where R naught is the resistance. R naught is the resistance at 273 Kelvin or at 0 degree Celsius, and RT is the resistance at T degree Celsius. Resistant at T degree Celsius, or means at 273 plus T Kelvin. So therefore, and here delta T is the temperature difference from with respect to the 273 Kelvin actually. So this is T minus 273. Now therefore RT, here it is written 0.3, that is equal to R naught into 1 plus alpha delta T. So that will be 300 Kelvin, it is 0.3 ohm. 300 minus 273. So it means that 0.3, that is equal to R naught into 1 plus 27 alpha. And is told 0.6 ampere at which temperature that is asked. That is equal to R naught into 1 plus alpha into T minus 273. So now if we take the ratio, then we will get 0.6 by 0.3, that will be equal to 1 plus alpha into T minus 273 divided by 1 plus 27 alpha. So alpha value is also given here. Now this is 3 to the 6, that is 2. Therefore, if we solve it, then we'll get 2 into 1 plus 27 alpha, that is equal to 1 plus alpha into T minus 273. So this will be equal to 2 plus 54 alpha is equal to 1 plus alpha into T minus 273. So this will be 2 minus 1. This is 1. So 1 is equal to 54 alpha plus alpha into T minus 273. So therefore alpha, if I take as common, then this will be 54 plus T minus 273, that is equal to 1. So therefore T minus, so this will be, if I subtract it, this will be 9, and then 6, 1. So 2 T minus 219, that is equal to 1 by alpha. Means T should be equal to 219 plus 1 by alpha, which is 1 by alpha, which will be equal to 1.5 into 10 power minus 3. This is 219 plus 1000, so 1000 into 10 divided by 15. If I say 15, 5 to the 10, so this is 219 plus 3, 6 are 18, then 18, 3 sevens are 21. So approximately this much Kelvin. This will be 7 plus 9, that is 14, 16, and 8, 886. So this is, sorry, this will be minus 54 alpha, minus 1. This will be minus, so this is, you have to add it actually. This is 7. This part is wrong, sorry. This part is wrong. So this will be T minus 7. This is 2. This is 3. So T minus 327, that is 1 by alpha. So T minus 327, that is equal to 1 by 1.5 into 10 power minus 3. That means T will be equal to 327 plus 1000 into 10 by 15. So this will be 5, 3 15, 5 to 10. So this is 1000. So this is 327 plus 667 approx. So this will be 7 to the 14. Then so 14, 6 plus 2, 8, 9, 994 Kelvin approx. So which is the closest answer? This is option C. So option C is the correct answer. So in question number 17, it's told that a battery of EMF E, a battery is there which is having EMF E and internal resistance R. A variable resistance capital R is connected to the terminals of the battery. So this is the R resistance. A current I is drawn from the battery. V is the terminal potential difference. So it means that V, the terminal potential, so I is equal to E by R plus R. So then V will be equal to terminal potential difference, which is E minus IR, is equal to IR also. If R alone is gradually reduced to 0, Which of the following best describes I and V? So I versus V graph we can draw. R is gradually reduced to 0. So V is equal to ER by, so I is this, V is equal to IR. So simply I can say V by, so I is equal to V by R. So when I approaches, so R is gradually reduced to 0. When R is 0, then I will be equal to, R tends to 0, I will be equal to E by R. The terminal potential difference V will be equal to, I approaches 0. Okay. R alone is gradually reduced to 0. So when R is reduced to 0, then I will be equal to E by R. V will be equal to 0. V will be equal to 0. Okay. So I, when R is tending to 0, then the current approaches E by R and V approaches 0. It means that option B the correct answer. Then in question number 18, told that 3 voltmeters A, B, and C having resistances R, 1.5 R, and 3 R are respectively are used in the circuit as shown. When a potential difference is applied in between X and Y, the reading of the voltmeters V1, V2, and V3 be respectively. So this resistance of A is R, resistance of RA is R, resistance of B, that is RB, that is 1.5 R, and resistance of C, that is RC, that is 3R. Then when a potential difference is applied in between X and Y, the reading of the voltmeters V1, V2, and V3. So this is V1, this is V2 across this, V3 across this. So potential difference E is applied across X and Y. Potential difference is V, suppose. So then the R equivalent will be this 1.5 R and 3 R are connected in parallel. Therefore, their equivalent is 3 R into 1.5 R by 4.5 R. Then with that R is connected in series, therefore we have to add that. This will be R will cancel, 15 3s are 45, then 3 cancel, so R plus R, that is equal to 2R. Therefore, how much current will pass through it? The current I will be equal to V. So how much current will be equal to V by R equivalent? That is V by 2R. Now therefore V1 will be equal to, now so I current will flow through it, so this is I into RA, so that is equal to V by 2R into R, so which is equal to V by 2, and V2 will be same as V3 since they are connected in parallel. Therefore the potential difference in between the voltmeters B and C will be the same. So V2 will be equal to V3, that is equal to V minus V by 2, means V minus V1 actually, which will be equal to V by 2. It means that all are equal, means V1 will be equal to V2 equal to V3. It means that option A is the correct answer. So hope you have understood the solutions of all these 18 questions. So in the upcoming uh, videos on current electricity, we shall solve the remaining um, questions on it. So here we shall end the first part of this video on current electricity. So if you are unable to understand any steps of these solutions or any other doubts if you have, then please write us in the comments section, and please install our Sapience education application, where we shall upload some very important previous year KCET questions which shall be helpful for your KCET exam. So thank you everyone. Bye.